Hello. In this section, we are looking at parametric curves. So we are introducing this new way to write curves or write equations to plot points. And so what a parametric curve is it is when the coordinates of a curve are expressed in terms of a parameter or another variable outside the equation definition. Lots of words to say. Instead of saying y equals f of x, this is known as a Cartesian equation. Instead of this, for parametric, we introduce this third variable or third parameter that is the independent variable, and now x and y both become dependent. So this would be x equals a function in terms of t, and y equals a function in terms of t. And we would plot the points x, y, which is also the points f of t, g of t. So t is not an axis on the graph, but it is this increasing number that defines x and y. And then we often will then also put limits on t and say t is going to be only between these two numbers. It could be from negative infinity to infinity, but sometimes it will be like from 5 to 7. And what happens is we then can create more curves than we were able to before, because now we've taken away this structure of needing a function, because before y and x had to be related to each other in very specific ways, but now x and y, they're their own thing, so it can create more curves. We have actually already experienced parametric equations without realizing that was what we had, because we know for the unit circle that we can name the x coordinate as cosine of theta and y equals sine of theta, where to get the whole unit circle, theta is going to be between 0 and 2 pi. So this is an example of a parametric equation. X and y are created into these other equations to give us ultimately a set of points that will graph the unit circle. And we'll take a look at more examples in the next few videos.